In this video, we review Boolean types and its related operations. Boolean type is to represent the true or false logic values. Keyword bool is of a Boolean type. So if I declare a variable of b, you can store true value, or if I have another variable, I can store false value. So Boolean types has only two possible values, true or false. So let's display those values on the screen with a blank separation and see what is displayed. So compile the program, run it. Instead of true false, 0 or 1 is displayed. So by default in C++, a true value is represented by 1 and false value is represented by 0. But in general, 0 is the only false value. Any non-zero value is to represent true value. So negative 1 is non-zero, it's still true value. If you really want to print on the screen true or false as those literal word, you need to give a manipulator to the cout stream. That manipulator name is a bool alpha, means alphabetic representation of a Boolean value. Now, as we compile again and run it, now true, false values are displayed. So Boolean variable is to store true or false value. If you think if that's about it, then you don't see any good application for that. But that is actually very useful to store the result of relational operators. Relational operators to compare values, two values, or three or one, and the like. So relational is always a two value comparison. So this symbol is greater than, this is less than, and this is less than or equal to, this is greater than or equal to. Two equal sign is for equality, exclamation mark equal sign is for not equal comparison. So if I have a Boolean variable v, where I can compare 3 and the 5 is less than, so this is true. But if I compare it this way, 3 greater than 5, so v should be false. It's greater than equal to, it's still false. Less than or equal to, it's true. So equal is for equality. Since they are not equal, v is a false. But if I give not equal to operator, then that's true value is stored. So the Boolean variable is to store the result of the relational operator comparisons. Here, one of the some popular trick is that I want to know if some variable is even value or not. So is it even becomes true. If n is even, then how do we find it out? Suppose integer n is a 5, then is even should be a false. So how do we do that is so n, and then we take a remainder after dividing by 2. So modulus operator takes a remainder only. If the remainder is 0, then that is even. So how to find the even or odd is divided by 2 and take the remainder only, that compare the remainder value. If it's 0, it's even. If it's 1, it is odd. So here we could do similarly, is odd, then the remainder should be 1 or not 0. Then that is how to find the even or odd of a given value. So using Boolean types, it is not just limited to store relational operation result. The Boolean types has its own Boolean operators as well. We have 3 Boolean operators. So 2 ampersand is for logical AND operations, so true and true, true and false. Like the 2 vertical bars are logical OR operation, and the exclamation mark alone is a logical NOT operation. So Boolean operators is working only on Boolean value, true or false values only. So you cannot apply logical AND or those ones on numbers or strings and so on. So Boolean operator is only for logic values. So using those Boolean operators, you can easily find a value if it's in given range or not. So in math, suppose n has a certain value, and then we want to find if n is between 0 and 100 in math. So this is a mathematical formula, and then that's a very correct one. But in C++, you cannot write this way. So let me show you that. Suppose int has a 10, then let's just see Boolean as a result. If n is in that range, not, then let's print m is. Then let's print, see how it works. Compile and run. So m is true. Yes, m is true because this looks correct. But however, let's change the value 1000. N is now 1000. Then we expect m should be false. But if we compile and run again, m is still true. So what is happening here? So let me explain that. So in C++, like many other programming language, a computer evaluates the expression one by one. So what I mean by that, if I have a 0 less than n less than 100, as I write the program this way, suppose n is 10, then computer evaluates less than operator one by one in the order, so from left to right. So this one is evaluated first. So n is 10, so this part becomes true. Then also remember that in C++, true is represented by 1 internally in the computer. So the whole part is just 1. And the 1 is less than 100, so the whole expression is true. That's why we had a true value displayed. Now n is 1000. And then let's evaluate this expression again. So left hand side is true, and is 1000, so it's true. So true is represented by 1 internally. Now again, 1 is compared with 100, so this is true. So that's why we had a true value even if n is 1000. So obviously we can see this is a very wrong. Then how do we fix that in C++? So in C++, using Boolean operators like AND or logic operators, you need to do this expression comparison in each step separately. So here in Boolean first step M1, let's just see if n is greater than 0. And then in second step is if n is less than 100. Then our result should be M1 is true and M2 should be true. So that is what we are looking for. Then let's put down here, and then let's delete that part. Then what we will get is a result is a false. So that's how we actually see if a value is in a given range or not. But as you become more and more experienced in the C++, you don't have to write those code in 3 steps. You can put all of those in 1 step as follows. Bool m should be n is greater than 0 and n is less than 100. So that's a compact, professionally written code for that. So you should utilize Boolean operators, something like this. Let's try another one. Let's see if n is negative less than 0 or n is greater than 99. Then how do we write an expression like this? So again, we need to do several steps. So step 1, see if n is negative. Step 2, see if n is greater than 99. Then what is then the result? The result should be m1, which is negative or greater than 99. So we now use a Boolean operator or operator, not and. So depending on the given problem expression, you should find whether and is appropriate or is appropriate. But anyway, using Boolean operators, you can check if a value is in a given range or not.